Hello everyone. Today I'm going to present about my final year project one. So let me introduce myself first. My name is Dineshwaran Anlaki Murugan. My matric number is 181151575. I am from Biomedical Electronic Engineering program. So my FIP supervisor is Dr. Nomahira Mamad. My FIP title is the effect of dispersing agent in fabrication of starch-based hydrogel. So for the overview part, there is some element that included in this page. So for the first part, we are going to see the background, followed by the problem statement, and then we going to see the objective and scope of studies. Later on, we will see the literature review and then the research methodology. Last but not least, we are going to see the expected results. So for the first part, it is about the background. So what is starch? So basically, starch is a polymeric carbohydrate consists of numerous glucose units joined by glycosidic bonds. This polysaccharide is produced by most green plant for energy storage. For the second part, we are going to see what is hydrogel. So hydrogel is a 3D network of hydrophilic polymers that can swell in the water and hold a large amount of water while maintaining the structure due to the chemical or physical cross-linking of individual polymer chains. So there are few types of hydrogel, which is natural hydrogel, synthetic hydrogel, and hybrid hydrogel. So hydrogel are very useful in biomedical application. So hydrogel are used to make contact lens and wound dressing. So it is also used in drug delivery system and tissue engineering. So for the problem statement part, the first problem we identify is the common synthetic hydrogel are fundamentally different from biological gels. Synthetic hydrogel is usually stiffer and less porous than the natural hydrogel. So for the problem 2, it is about the use of dispersing agent in order to fabricate starch-based hydrogel, as also shows a great ability in production of starch-based hydrogel. However, there are still no available literature that provide exact information on the use of different styling method in order to fabricate starch-based aerosol. So for the objective part, there are two objectives. The first objective is to fabricate starch-based aerosol with different concentration of starch and gelatin by using different temperatures. So for the second objective, it is about to investigate the usage of different amount and types of dispersing agent used in starch-based aerosol. So for the scope of study, there are three scopes. For scope 1, it is about the agitation method, which is magnetic stirrer with constant speed are used to fabricate the starch-based aerogel. So for scope 2, two different types of natural chemical powders, which are starch and gelatin with some different ratio combination, are used to study the fabrication of aerogel. So for the scope 3, three different types of dispersing agent with three different amount, which are alginate, Arabic gum, and santan gum, are used to study its effect on fabrication of starch-based aerosol. The amount of dispersing agent going to be used are 3 gram, 4 gram, and 5 gram respectively. So next we are going to see about the research methodology. So for the first part, I was preparing the gelatin solution. So the first step is the gelatin powder was dissolved in the distilled water to produce gelatin solution. So the gelatin powder was measured by using electrical analytical weight machine. So 6 gram of gelatin powder is used to dissolve in 50 milliliter of distilled water. So the distilled water was heated up to 100 degrees Celsius using hot plate. After the temperature achieved 100 degrees Celsius, the gelatin powder was added and stirred about 30 minutes by magnetic stirrer to make sure it heat evenly. So the temperature must be maintained constant at 100 degrees Celsius in order to prevent gelatin powder from coated. So later on, measured 9 ml, 7 ml, and 5 ml, 3 ml, 1 ml of the solution respectively, and pour into a small beaker for each. So for the second part, I was preparing the starch solution. So the starch powder was dissolved in the distilled water to produce starch solution. So the starch powder was measured by using electrical analytical weight machine. 3 gram of starch powder is used and dissolved in 25 milliliter of distilled water. So the distilled water was heated up to 60 degrees Celsius using hot plate. After the temperature achieved 60 degrees Celsius, gelatin powder was added and stirred about 10 minutes by magnetic stirrer to make sure it heated evenly. So later on, I measured 9 ml, 7 ml, 5 ml, 3 ml and 1 ml of the solution respectively, and pour into a small beaker for each. So finally, for the hydrogen sample preparation, the solution of gelatin and starch are combined with the concentration ratio of 9 ml gelatin plus 1 ml of starch, 7 ml gelatin plus 3 ml of starch, 5 ml of gelatin plus 5 ml of starch, and 3 ml gelatin plus 7 ml of starch, followed by 1 ml of gelatin plus with 9 ml of starch. This solution was stirred using magnetic stirrer under 60 degrees Celsius for 20 minutes. So later on, all the solution were transferred into a petri dish respectively. All those petri dishes were placed into a micro oven under 60 degrees Celsius for 3 hours. So finally, it is about the characterization test. So all the results will be characterized by using the scanning electron microscope, which is known as SEM, and then followed by the Fourier transform infrared spirometer, which is known as FTIR. Later on, we will use the degradient test, spinning test, and tensor test to test all the samples. So for the expected result, the suitable ratio for combination of starch and gelatin to fabricate starch-based hydrogen can be identified, and starch-based hydrogel with more suitable amount and type of dispersing agent can be obtained and achieves the requirement for biomedical application as for wound healing and drug delivery system. So last but not least, the starch-based hydrogel have excellent biocompatibility and biodegradability. So that's all from me. Thank you.